Hello. So today we're going to be doing our next lesson, which is Proving Congruence SSS and SAS. The last lesson you learned about CP/CTC, congruent parts of congruent triangles are congruent, where they gave you two triangles that were congruent, and then we just had to show that either the angles and the sides were congruent based on that postulate. So now we're going to break it down where we have to actually prove that the two triangles are congruent. There's going to be 4 ways that we're going to learn, but today we're going to do 2, which is SSS, which is side, 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 and SAS, which is side, angle, side. So the objective is, how do we use SSS and SAS postulate to test for triangle congruence? For the side, side, side congruence, which is SSS, it states that if the sides of one triangle are congruent to the side of a second triangle, then the triangles are congruent. So the abbreviation for it would be SSS. So we're going to do examples based on side, side, side postulate. So they say to look at each set of triangles in the chart, then list the sets of congruent corresponding sides and explain how you know. Then name the congruent triangles. So we have the 3 sides that we have to prove that they're congruent, and then the last part, the last column shows that we have to write the triangle congruency statement. So before I even do anything, I'm going to look at the triangles and highlight what is congruent. So for ABC and XYZ, I see that AB has the same marking as XY, so I'm going to highlight that in green. Then I see that BC and YZ are also congruent because of the marking is 2 markings, so they're congruent. And then XC and AC are also congruent because they have 3 markings. So then I will highlight that in pink, well, magenta. All right, let's start doing the congruency statements. So first one will be green. So it says, show that AB is congruent to XY. And the reason is, it's given. If they put a marking on the triangles to show that they're congruent, then it is deemed as given. Then I go to the next one, which is blue. So it's BC is congruent to YZ because it's also given. Okay, and I'm just going to erase that because that looks like a little hat. Okay, and the next one, which is the magenta, shows AC and XZ, which are also congruent. So put AC is congruent to XZ, and same reason, it's given because of the marking. So now I can write a triangle congruency statement, which will be triangle ABC is congruent to triangle XYZ. So that's all you have to do. Anything, if they give you a marking or any information, then you just write the congruency statement and then the reason why. All right, the next one, we have triangle ACB and triangle DCB, and they say that B is the midpoint of AD. So I'm going to start marking stuff by highlighting it. Get the green. So I see that AC has the same marking as CD. So I know that they're congruent. The next one, they said that B is the midpoint of AD. So that means AB is congruent to BD. So I put a similar marking. Now for the third side, if I were to look at it, before I even do anything, I'm going to make this blue. The third side would be CB. And I'll use magenta, actually the highlighted magenta for that one. CB is going to be congruent to CB because of the reflexive property. because these are two different triangles. I mean, two similar triangles. They're sharing the same side, so then that side is going to be, the third side is going to be congruent to itself. So now I'm going to write the statement for each side. So we have AC, which is congruent to CD because it's given. Then the next one is going to be AB is congruent to DB because definition of midpoint. That's the reason. They give us that B is the midpoint of AD, and this is basically based off the definition of midpoint. And then CB is congruent to CB is congruent to CB, and it's because of the reflexive property. I'm going to abbreviate that. It's reflexive property. So now then I can write the triangle congruency statement, which will be triangle ACB is congruent to triangle DCB. And I forgot to put it, it's the postulate is SSS. That's the reason. SSS. Side, side, side. Is congruent to the other side, side, side. Right. Let's do another example with where they have numbers. So we have a quadrilateral, and I'm going to just highlight the sides that are congruent. This side, KL, is congruent to JM, and then I have that, use blue for that. I have LM, which is congruent to KJ because they're both 5. And the last one will be JL is going to be congruent to itself because this is two triangles. They're congruent, so they're sharing that same base. So now I can write the congruency statement. The first one will be the green one. So I have KL congruent to CKL congruent to MJ. And I'm going to put given because it shows that both of those sides are 6, so they're congruent. And then the next one is going to be LM congruent to KJ. That's also given because you see the number 5. They're both 5, so they're the same. And then the last one, which is JL. And I'm going to put a little X on that. That tells me that this is reflexive to itself. It's congruent. So that's JL congruent to LJ. And it is because of the reflexive property. And then I can write the triangle congruency statement. So I have triangle JKL is congruent to triangle LMJ. And it's because of side, side, side postulate. SSS. Right. So I'm not going to do these other two examples because basically, if you look at it, you'll see that you just match up the sides that's congruent to the other side, and then you write your triangle statement, and it's going to be side, side, side because all of the sides are marked. Same thing with this rectangle, just like the one we just finished. You just look at the two 9s, they're congruent, the 5s are congruent, and the side MP also congruent because of reflexive property. Alright, let's go on to the next one, which is side angle side congruence. And the definition for that, or the statement for that, is if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. And the abbreviation is SAS. You can write SAS or SAS postulate. Okay, so we're going to do examples based on SAS. We have triangles, and now we have to write congruency statements for the sides and also the angles. So the first thing I'm going to do is highlight. So I'm going to start off with green. So I'm looking at how both of them are positioned. We got a side, we got an angle, we got a side. Same thing with EG, triangle EGJ. I got a side, an angle, and a side. So I'm going to highlight this first, and the same thing with EG. And then I'm going to do the angle. Highlight that in blue. So I got the M, and then I got G, so I'll make this bigger. And then the last side, which will be in magenta. I got MR, and then I got GJ. Alright, the first one in green, I got KM is congruent to EG, and the reason is it's given because of the marking. It says that they're congruent. Now for the angle. The angle, I got angle M is congruent to angle G because it's also given. They have a little marking to show you that it's congruent. And then I have my second side, which is MR, congruent to GJ, and it's also given because of the marking. So now I can write my triangle congruency statement, which will be triangle KMR is congruent to triangle EGJ, and the reason is, oops, let me do that again. Reason is SAS, side angle side. All right, let's do the next one. So I got two triangles sharing the point N, and now I'm going to highlight the ones that are congruent to each other. So I got MN, which is congruent to PN, because they have that one mark, one congruency mark. Then I have NO congruent to NL, because they have two markings, so they're both congruent. And now for the angle. If you remember back then when we were talking about types of angles, when you have two lines intersecting each other at a common point, they create vertical angles. So this angle, MNL and ONP, are going to be congruent. And I'm going to mark that with purple. So this angle and this angle are congruent because of their vertical angles. Alright, so now we can write our congruency statements. The first side, we have MN congruent to PN because it's given because of the mark. Then we have the angle that we found, which is angle MNL congruent to angle PNO. And because for this vertical angles, definition of vertical angles. Definition of vertical angles. So that's all you have to write. You don't need to write, oh, vertical angles are congruent. Just put definition of vertical angles. And then the last one would be ON congruent to LN. And that's given. And the triangle congruency statement would be triangle MNL is congruent to triangle PNO. And the reason is SAS, side angle side. Alright, so that's how you would do for side, 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 and side angle side. The first thing you would do to make it easy for yourself, mark it up. Highlight it. Anything that, any sides that are congruent to each other, any angles that are congruent to each other, mark those up first. Then you can write the congruency statement. And another thing, notice how when I, especially for the second example, I have MN and then I have PN. Notice that the order matters with that, because if I start M here, I start at my line outside here and then go inwards, I'm going to do that for the same one. So order matters. So if I start outside, then the same thing with the other congruent line. I start with the P first and end up with the N. And angles. Most of you might get into the habit and try to put angle N is congruent to angle N. You need to write it all out because this vertex, this point, is being shared by two triangles. So you telling me angle M, N, I might think you're talking about the one outside here or here. So you need to actually write it. If there's only one triangle, you can put angle M, N, or angle L, then I know it's for that one triangle. But if there's two triangles put together and they share a common point, you need to specify the three letters for that angle. So this one's M, N, L, and then P, N, O. You need to specify. All right, let's do one more. I'm going to choose the top one. So the first thing I'm going to do is mark up anything that I think would be congruent. So we have K, L, and M, J, which are congruent because they're both 6. And now I have the angle marking. Put that in purple. So I got angle KLJ and then angle MJL because of the marking, so they're congruent. And then because there are two triangles put together, they are sharing the same side, and that's J. Oops, I should put that in green. Let me undo that. They're sharing the same side, which is JL. So that's going to be, they're going to be congruent to each other. And I'm going to put that little X there that tells me that's a reflexive property. So now I'm going to write the congruency statement. So I have JL congruent to MJ, and that is given because both of them are labeled as 6, so they're congruent. Then my angle is angle KLJ congruent to angle MJL, and that's because of the reflexive property. So I'm just going to put reflex prop. And then the last one for the line, the side, is going to be, oops, I need that green. It's going to be JL is congruent to LJ because, oh, this one's supposed to be reflexive property. This is the reflexive property. And then this one, the angle one, should be, so that's a mistake here. This one should be given because of the mark. So that's given. Now I can write the triangle congruency statement. So I have triangle KLJ is congruent to triangle MJL because of side, angle, side, SAS. Okay. So when it comes to doing proofs, when you have a statement and reason, especially when you have to prove that triangles are congruent, there are steps that you have to follow. First one, it says determine what the theorem you will use to prove the triangles are congruent. Then in the margin, list 3 sets of corresponding parts that you must prove congruent. And then third, list the first piece of given information. Then 4, list, justify, and label what follows from it. And then 5, repeat step 3 and 4 for all given information. And then 6, when you have 3 corresponding parts justified and labeled in your proof, make and justify the final conclusion. So these are just the steps when you have to do proofs, especially when you have to prove that triangles, the 2 triangles that they give you, are congruent. So we're going to use those steps in order to do a few examples. So for the first one, we have a given statement. They said RS is congruent to UT. So while I'm reading that, I'm going to start highlighting, even if they have the marking. So I see that RS is congruent to UT. And then they said that RT is congruent to US. So I'm going to highlight that and even though they have the marking, so this has a marking, this has a marking, so those are given. They want us to prove that triangle RST is congruent to UTS. So in order to do that, we need three statements. The three statements, whether it's a side, 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 or side, angle, side, in order to prove that the two triangles are congruent. So they already gave us the statements. So now we just have to fill in the reason for those statements. So the first one is RS is congruent to UT, and that is given because they gave it to us in the beginning. They said that RT is congruent to US. That is also given. So we write our reason as given. Then they said that TS is congruent to ST, and I'm going to use a highlighter, and then I'm going to purple, and then I'm going to make a little mark here that tells me that these are congruent, and the reason is reflexive property. So reflexive property, it's like if you're looking at yourself in the mirror, it's congruent. And now I can prove that this triangle is congruent because I have those three sides that I showed that were congruent. So the reason is SSS postulate. Okay, so that's how you do this one. Now the next one, they gave us they said that RQ is parallel to ST. So you can see by the little arrow heads, which I will actually, you know what? Yeah, I'll show this. So they're just telling me that this is parallel to each other. All right, and then they said that RQ is congruent to ST. So I'm going to highlight that in blue. So these two are congruent to each other because of the marking. They want us to prove that QRT is congruent to triangle STR. So they already gave us the statements. Now we just have to give the reason why they are congruent. So for the first one, they said that RQ is congruent to ST. It's given. They gave it to us in the beginning. They said that RQ is parallel to TS. That's also given. So you write the word given. Now they said that RT is congruent to TR. So I'm going to use the green highlighter. Try that again. And then the reason why is reflexive property. So I'm going to put reflexive property. Just abbreviate to reflex prop. And now they said that angle QRT is congruent to angle STR. So QRT is congruent to STR. And the reason for that, again, if you remember back to our special angle pairs, when you have two parallel lines and you have a transversal, so QR and ST are parallel lines and RT would be the transversal. When you have that, you have two angles that are on opposite side of the transversal and they're inside the parallel line. So it's the definition of alternate interior angles. The definition alternate interior angles. That happens when you have two parallel lines and a transversal cutting through them. And if the angles are inside the parallel lines and opposite side of the transversal, it's alternate interior. And you remember that alternate interior is congruent. So those two are congruent. Now you can prove that the two triangles, QRT and STR, are congruent because of side, angle, side. So side, angle, side. Again, this is everything that you've learned from previous lessons. You're just putting it together to prove that two triangles are congruent to each other. So nothing new. You're just taking everything you've learned before and applying it for a proven triangle congruency. Okay, let's see. We have one more. So it says, given the triangle CDE is isosceles. Remember, isosceles has congruent sides and congruent bases. They said G is the midpoint of CE. And they want us to prove that CEG is congruent to EDG. All right, so you have all the statements here. The statements they're written in a certain order, so we're going to follow through. So it says that CDE is an isosceles triangle, right? So since they said that, they said it here, so that's given. The next one, they said that CD is congruent to ED. That's also given, because you can see over there. So I'm going to highlight in blue, so that way you notice that. I'm going to write that in blue. So that one is given. They said that G is the midpoint of CD. Actually, it should be CE. Let me change that. That should be CE. That's a typo. And that is given. Oops, the V, why is it looking weird? Alright, so then if G is the midpoint of CE, then they said the next step, they said that CG is congruent to EG. And the reason why, so I'm going to mark that up. So this, 2 marks, is congruent to that, and I'm going to highlight that in green. And the reason why those two are congruent to each other is because of the definition of midpoint. So they gave us the definition before that. They said that G is the midpoint. So when you have a midpoint, it creates 2 congruent segments. So that's why CG is congruent to EG, because of the definition of midpoint. Now they say that DG is congruent to DG. And I'm going to mark that. And notice that there's 2 triangles. They share the same side. So it's going to be a reflexive property. I'm going to highlight that. Right. And then right. So this is because of the reflexive property. Now that we've already got our 3 sides and we proved them to be congruent to each other, now we can say that the 2 triangles are congruent because of side, side, side. And we've concluded that triangle CDG is congruent to EDG. Right. So that's the end of that. So we're going back just to recap. We learned about proven triangle congruency. We learned about side, side, side. So once we prove that all the sides are congruent, whether it's given or we have to show it, then we have proven that the triangles are congruent by side, side, side. And the other one that we learned was side angle side. If I can get back to that page. Side angle side, where you have an angle between the 2 sides and the 2 sides are congruent to each other. Once you have all those 3 factors, then you can prove that the triangle is congruent by side angle side. All right. We've reached the end of this lesson. It's going to take a while to understand and try to create proofs when it comes to these triangles. But again, if you have any questions, you know that you can email me or ask me during class, so that way you get a better understanding. All right, so this concludes our lesson, and have a nice day.